Imagine you are falling. Not tripping. Not stumbling. Falling through space, in total silence, towards something you cannot see with your own eyes, but can feel pulling on every atom in your body. Your ship's instruments are screaming numbers that don't make sense anymore. Time on your clock is ticking slower than the clock back home. And somewhere ahead of you, invisible, patient, waiting, is a wall in space that nothing has ever crossed twice. You have 30 seconds before physics stops being a suggestion and becomes a sentence. At first, it's beautiful. From a distance, a black hole doesn't look like a monster. It looks like art. A perfect ring of golden light bends around a circle of pure black, as if the universe itself folded space into a halo. This is light from stars behind the black hole, dragged around it, wrapped into a glowing loop by gravity so strong it turns straight lines into circles. Astronomers call this a photon ring. Tourists in some distant future might call it the most beautiful thing they've ever seen. It looks peaceful. Still. Almost holy. But something is wrong. That stillness is a lie. What looks like a calm, glowing eye in the dark is actually the edge of one of the most violent objects in the known universe. A place where the rules that hold reality together begin to break down. And you are drifting closer to it every second. Here's the first thing that should terrify you. You have no idea how big this thing actually is. Some black holes are only a few miles across, born from the collapsed core of a dying star, but they can weigh more than our entire sun. Others are supermassive black holes, the kind that sit at the center of galaxies like ours. They can be billions of times heavier than the sun, powerful enough to dominate everything around them. The one at the center of the Milky Way is called Sagittarius A star. It has a mass about 4 million times greater than our sun. Astronomers didn't even obtain the first direct image of its surroundings until 2022, using a network of telescopes spread across the entire planet, working together as if Earth itself had become one enormous telescope. And now imagine you are approaching it. Your spacecraft is moving forward. The stars ahead are beginning to bend. The darkness grows larger. You are not approaching an ordinary object. You are approaching a region where space and time themselves have been distorted by unimaginable gravity. Something that has existed for billions of years. Something that has been sitting there in the darkness, silently feeding. And here's the problem. Mass isn't even the scariest part. Because the closer you get, the more dangerous physics becomes. Every black hole has an invisible boundary surrounding it. The event horizon. There is no wall. No warning light. No flashing sign telling you that you've gone too far. You could cross it without feeling anything unusual. But after that moment, everything changes forever. Inside the event horizon, escaping would require moving faster than light. And nothing in the universe can do that. Not a spacecraft. Not a radio signal. Not light itself. Once you cross that boundary, there is no route back home. No message can escape. No photograph can escape. No signal can ever tell anyone what happened to you. From far away, someone watching your spacecraft would see something strange. As you approach the event horizon, your movements appear to slow down. Your signals become weaker. The light coming from your ship becomes increasingly stretched, dimmer, and redder. To the observer watching from a safe distance, you seem to freeze near the edge of the black hole. But from your perspective, something completely different is happening. You keep falling. Your clock keeps moving. Your spacecraft continues forward. There is no invisible wall stopping you. No sudden explosion. No warning. You simply cross the event horizon. And you may not even know the exact moment it happens. But after that moment, the universe outside is no longer reachable. The stars behind you can still exist. The distant galaxies can still shine. Earth can still be billions of light years away. But none of that matters anymore. Every possible path forward leads deeper into the black hole. There is no turning around. No engine powerful enough. No escape trajectory. No signal that can outrun the darkness. And this is where the story becomes even more terrifying. Because the black hole doesn't need to destroy you immediately. Instead, it begins to change what gravity means to your body. As you fall deeper, gravity does not pull equally on every part of you. Your feet are slightly closer to the black hole than your head. That difference might seem insignificant from far away. But near a black hole, it becomes catastrophic. The gravitational force on your feet becomes stronger than the force on your head. And your body begins to stretch. At first, the effect would be almost impossible to notice. Then it becomes stronger. Your body is pulled longer and thinner along the direction of the black hole. The same gravity that pulls you downward begins tearing you apart. Scientists have a disturbingly simple name for this process. The stretching doesn't stop. Every second you fall deeper, the difference in gravity between your head and your feet becomes more extreme. Your body is being pulled in two directions at once. Your feet are being dragged toward the black hole faster than your head. The force becomes so enormous that your body begins to elongate, thinner and thinner, as though invisible hands are pulling you apart. This is spaghettification. At first, your body resists. Your muscles. Your bones. The tissues holding everything together. But gravity doesn't care. The stretching continues. The structures inside your body begin to fail. Eventually, even the molecules that hold your cells together can no longer withstand the tidal forces. You are no longer a human being falling through space. You are becoming a stream of matter following the geometry of the black hole. And the terrifying part is that this destruction isn't caused by some explosion or weapon. It is simply gravity. The same force that keeps your feet on Earth. The same force that keeps the moon in orbit. The same force that holds galaxies together. Here, that familiar force becomes something unimaginable. But there is an important detail. Not every black hole would tear you apart at the event horizon. A smaller stellar mass black hole can have extremely strong tidal forces near its horizon. A supermassive black hole can have a much larger event horizon, meaning you could potentially cross it before the tidal forces become immediately lethal. But eventually, deeper inside, the difference in gravity becomes unavoidable. And then something even stranger happens. Your understanding of space begins to collapse. Because according to our current theories, at the center of the black hole lies something called a singularity. A place where our equations predict conditions so extreme that density becomes effectively infinite. Space and time themselves become impossible to describe using the physics we currently understand. Einstein's equations brought us to this point. But they cannot tell us what happens beyond it. And that is where our knowledge ends. We have theories. We have equations. We have observations. But we don't have the answer. Because no one has ever seen what lies beyond the event horizon. And perhaps the most terrifying question isn't what a black hole does to your body. It's what happens to information about you after you disappear. At the center of a black hole, our understanding of reality reaches a wall. We call it the singularity. According to classical general relativity, it is a region where matter is compressed to an extreme state and the curvature of spacetime becomes mathematically infinite. But there is a problem. When our equations produce infinity, it often means the theory itself has reached its limit. Einstein's theory of general relativity can describe gravity on enormous scales. Quantum mechanics can describe the strange behavior of matter and energy on microscopic scales. But inside a black hole, both worlds collide. And our two greatest theories stop agreeing. We don't know what actually happens at the center. Maybe the singularity is real. Maybe it is replaced by something completely different by a future theory of quantum gravity. Maybe information about everything that falls into a black hole is somehow preserved. This question became known as the black hole information paradox. Stephen Hawking spent decades thinking about it. Some physicists have proposed that information could somehow be encoded on the event horizon, almost like a two-dimensional description of everything that fell inside. This idea helped inspire the holographic principle. Other theories have explored stranger possibilities, including hypothetical connections through spacetime. But these remain theories. Possibilities. Not confirmed escape routes. And that is what makes the black hole so frightening. We have photographed the shadow of a black hole. We have detected black holes merging across billions of light years. We have measured their gravitational waves. We can calculate their mass. We can predict their motion. We can watch stars orbit invisible black holes. But we still cannot look inside. There is a boundary beyond which observation becomes impossible. A place where information cannot return to us in any ordinary way. And somewhere beyond that boundary. Maybe you think the answer is simple. Just stay away from the black hole. But that isn't always enough. Because a black hole can be dangerous long before you ever reach the event horizon. Look at what happens to matter around it. Gas, dust, and stars can be pulled toward the black hole, accelerating as they spiral inward. The material doesn't simply fall straight down. It forms a gigantic rotating structure called an accretion disk. Matter crashes into matter. Friction and compression heat the gas to millions of degrees. The disk can become so bright that it outshines entire galaxies. And suddenly, the black hole that looked completely dark from a distance becomes surrounded by one of the most violent environments in the universe. But the danger goes even farther. That superheated material can produce enormous amounts of X-ray and other high-energy radiation. Some actively feeding black holes can also launch gigantic jets of particles from their surroundings. These jets can travel outward at speeds approaching the speed of light. They can extend for thousands, sometimes millions, of light years. Imagine approaching a black hole and realizing that you don't actually need to fall inside it. You only need to be close enough. A powerful burst of radiation could reach your spacecraft before gravity ever has the chance to pull you across the event horizon. Your instruments would detect the radiation. Your shielding would begin taking the impact. And then the warnings would become meaningless. Because the black hole doesn't need to touch you. Its environment can do the damage for it. This is the strange contradiction of black holes. The central region is completely dark. But the space around some black holes can become brighter and more violent than almost anything else in the universe. And the larger the system becomes, the more difficult it is to comprehend. Some quasars are powered by matter falling toward supermassive black holes billions. In 2015, something happened that changed our understanding of black holes forever. Two black holes, each dozens of times more massive than our Sun, had been spiraling toward each other for millions of years. Then, 1.3 billion light-years away, they finally collided. The collision released an enormous amount of energy. But there was no explosion that we could see. Instead, the collision sent ripples through spacetime itself. Gravitational waves. They traveled across the universe at the speed of light. And eventually, those waves reached Earth. An instrument called LIGO detected them as an incredibly faint signal. A tiny disturbance. A brief chirp. But that signal carried something extraordinary. For the first time, humanity didn't simply observe the consequences of a black hole. We felt one. And yet, after everything we've learned, the deepest fear remains. The universe was never built with a place for us in mind. We evolved on a thin shell of rock, warmed by one ordinary star, protected by an atmosphere that is unbelievably fragile compared with the scale of the planet beneath our feet. We live in a tiny region where the conditions happen to be right for life. And beyond that fragile home are objects so powerful that they can trap light itself. They don't need explosions. They don't need weapons. They don't need to chase you. A black hole simply waits. If you cross the wrong boundary, there is no rescue. No message. No final photograph. No wreckage floating back into space. Eventually, even the light carrying your last image becomes unreachable. And that may be the real horror. Not the crushing. Not the stretching. Not the radiation. The silence. Because somewhere out there, right now, black holes are still forming. Still merging. Still feeding. Still bending the light of distant stars. And somewhere in the darkness, one of them is waiting. Not for you specifically. It doesn't need to.